This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, I'm going to talk about Pythagoras' theorem and a little bit about the area of a triangle and the area of a parallelogram. Now, you might be familiar with the Theorem of Pythagoras or Pythagoras' theorem from your study of trigonometry, rather. It states in its short that h squared, the hypotenuse squared, is equal to o squared plus a squared, the sum of the squares of the opposite and the adjacent. But the theorem in full reads slightly differently. It says, in any right-angled triangle, the square of the hypotenuse is the sum of the squares of the other two sides. And this can be seen clearly by drawing a right-angled triangle, such as this one here. We have three sides. The hypotenuse, the one opposite our right angle, has length 5. The other two sides have length 4 centimeters and 3 centimeters. And what Pythagoras' theorem is saying is that if you draw a square on each of these sides of length 4 centimeters in this case, 3 centimeters in this case, and 5 centimeters in this case, so if we draw these squares in, this will be a 4 by 4 centimeters squared. So 4 times 4 is 16 centimeters squared. 3 times 3 centimeters is 9 centimeters squared. And the square on the hypotenuse will be 5 times 5, which is 25 centimeters squared. And if we look at these three numbers, we can easily see the result of Pythagoras' theorem, because we have 25 centimeters squared is equal to 16 centimeters squared plus 9 centimeters squared, because 9 plus 16 is 25. So Pythagoras' theorem might pop up from time to time in your geometry proofs, so it's good to look at it again here. Next, we're going to take a look at area of a triangle. Now, from your study of other sections of the course, you'll have probably learned many different formulas for the area of a triangle. The most common being a half base length times perpendicular height. From trigonometry, you may have learned these three formulae: a half AB sine C. From your coordinate geometry, you may have learned a half times x1 y2 minus x2 y1. And again, from trigonometry, you may have learned this formula involving this quantity s, which is a plus b plus c over 2, where a, b, and c are the lengths of the sides of your triangle. The one we're going to look at in particular, though, is this half base times perpendicular height, because when we do, it'll allow us to have a neat little trick for solving the area of a parallelogram. So we know that a half our base length times our perpendicular height is the area of a triangle. But one important thing to note is that it doesn't matter which side of this triangle you use as your base in that calculation. So in this case, I've used this as my base length, but I could have just as easily taken this side over here to be my base length, so this purple side here, in which case my perpendicular height would have been this side over here would have been my perpendicular height. Or, just as right, I could have taken this small side here to have been my base length, and my perpendicular height in that case would have been this length over here. So it doesn't matter which side of the triangle you use as your base length, you just have to remember that the height you measure has to be the perpendicular height, or the height at right angles to your base. The neat little trick I mentioned before is what we can do with a parallelogram. If I just draw one over here, right down here, if we draw a parallelogram, say like this, what we can do, so we have two sides parallel and the top and bottom side are parallel, we know that the diagonal of a parallelogram divides it into two equal triangles of equal area. So if I draw one of the diagonals of this parallelogram in, what we end up with is two different triangles. So one here, this green triangle, and another one up here in red. So we end up with two triangles that actually have equal area. But we just said up above that the area of a triangle can be half your base times your perpendicular height. So if we use that for these two triangles, this red one and this green one, well, we know that that area will add up to the total area of this parallelogram. So the area of a parallelogram can be given by a half base times perpendicular height. So that would be for our red triangle, plus a half base times perpendicular height for our green triangle down below. So that means that since we have a half base times perpendicular height plus a half base times perpendicular height, well, if you have half of something and you add another half of the same thing, then you'll get just base times perpendicular height. So the area of a parallelogram is just base times perpendicular height. So say, for example, I take this bottom side to be my base, then I just need to work out this perpendicular height here to get the area of my parallelogram. So this is my perpendicular height. So that's an easy little trick that you can use in some questions that involve parallelograms.